right, so I think we're going to go ahead and get started. I wanted to thank everyone for coming back after lunch. I wanted to introduce Salman, who's a distinguished engineer with Cisco Systems, has been involved in IPv6 for a long time, helped found the IPv6 task force in Texas, so the Texas IPv6 task force, has kindly hung his hat on the California v6 task force now that he's moved out here, and I will let him do the remaining introductions. Thanks so much.
All right, good afternoon, everybody. So after the lunch, right? So one thing, I kind of made sure that we're not going to have any slides in this panel discussion. So it's going to be more interactive, so we keep everybody awake. So today, we have 4 of our panelists, as you can see, today with us. So I would like to briefly introduce them and first of all, thank everybody to, be part of this panel discussion. And as you can see, the name of this panel discussion is about enterprise deployment and IPv6 enterprise deployment and some of the lessons learned, right? So all the panelists over here, they have been heavily engaged in IPv6 deployment within an enterprise network. So from my all the way to the right, John Woolwine is over here, who is one of the Cisco Distinguished Engineer, and he is part of the Cisco IT department, and he's been heavily engaged from last several years from where we started the IPv6 deployment to this day. So thanks for John for joining the panel. Then we have John Loughney, and I asked him, I think I pronounced your last name correctly. He's the head of the technical community inside the CTO office in Nokia, and also a V6 Forum fellow, and heavily engaged in IETF work and IPv6 working groups, and also within the Nokia's enterprise deployment of IPv6. Then we have Rich Lewis over here, who has graciously enough, flew in from Texas, Dallas, Texas, my old place where I used to live in Richardson, Texas, close to that. So Rich has come from there, and he's basically the global project manager for Oracle IPv6 global project manager for all the IPv6 deployment within global enterprise network within Oracle, and he's been heavily engaged in all the work which has been going on globally within the Oracle as an enterprise. Then I have Patrick Chang, who is the senior regional architect of F5, which is one of, as you know, pretty good-sized company, and working on a special, the load balancers and the area, which is very significant when you talk about IPv6 Internet Edge. So he's based right here, and have been engaged in all of the work, which of course F5, the product line they make, but specifically from the enterprise deployments, from the Internet Edge perspective, and how to provide that capability. So this is basically the whole panel we have over here. So the next 1 hour or so, we'll kind of keep it interactive. Initially, what I'll do that, I have some few general questions which I'll ask the panel, all the panelists, and then basically maybe some of those questions you have in your mind might get answered. If not, I'll take questions from the audience in the later part of the discussion. So first, one of my first questions is to the panel, and then maybe from the right, John, you could start, and then everybody else can chime in on that, because these are more general questions which we have prepared. The first one is, what has been your biggest challenge to adopting IPv6? So now, basically, since all of these individuals have been engaged in the deployment, rolling out of IPv6 within their enterprise networks, right? So this is more of a general questions, the first question for the panel.
How's the sound doing? Good? Okay.
Yes.
2 years ago, I would have answered you and said technology. But over the last, I'd say, year, most of the biggest challenge has actually just been engagement across our entire IT organization. So as we heard from other people here, success with IPv6 doesn't just start and stop with the networking team. It really spans the entire stack of IT. It's been a real challenge over the last year to get the people that play higher in that stack, especially the application folks, to sit down and play ball. The whole experience behind World IPv6 launch was an interesting one for us. It was the first time we, as a collective IT organization, said we're going to do something with IPv6, and it was successful, obviously. Now, when I look back on that, just to give you a sense of how widespread of involvement that effort had within my IT organization, my CIO has my CIO has 9 direct reports. It took people from 7 of her direct reports teams to make this successful. So as you can tell, the touch is pretty wide there.
For me, excuse me, having initially helped to deploy a research network in the CTO office quite a number of years ago, getting it up and running in a sort of research environment was actually pretty straightforward. I mean, we worked with suppliers and we were able to put things up and basically, as some of the other earlier sessions were talking about, having volunteers who were engaged worked really well. And basically, it was pretty straightforward to do that. However, when we go and try to turn it over to a production enterprise network, that's where things get very tricky. Those networks can be very complicated when you're talking about different proxies, different gateways, getting firewalls, getting the client software, client gateway, VPN, et cetera, that you just start building up these layers and layers and layers. And when one of them does not play nicely with IPv6, it will stop things very, very quickly, and also really start to get sort of disincentives from people on the IT staff. The other thing also which we found was, since we are also working in deploying IPv6 for services and customers and carriers, that quite often people who are really good in that area in our IT would also get pulled out to actually go and work with what we were deploying. So continuously, it was also just an issue of getting people who are knowledgeable, interested, and engaged. So those things really caused some problems in getting the intranet deployed with IPv6.
Thank you.
For us, it was really engaging our champions to help us spread the message and to help us kind of get over that initial hurdle of adoption, so that we could tell our managers and directors and show them there really was a benefit for adopting IPv6. And by enlisting these champions, we were able to identify processes where we could promote automation or even increase our time to delivery so that they were getting solutions quicker and satisfying their customers faster to improve their overall satisfaction.
Actually, the hardest part for us in getting IPv6 stuff going was getting good over-the-internet IPv6 testing going. Our entire support organization has IPv6 within their lab environment, but as soon as they wanted to get out onto the internet, it turned into IPv4. So, and what happened is the first step was we would help our customers set up IPv6. You just call the ISP, oh, here's your IPv6 address. And with an F5 device or any reverse proxy, it's very simple to just say, here, now you have an IPv6 service, and I can connect it to your existing infrastructure, whether it be IPv4 or IPv6. But then how do I test it to make sure that it's working out, over the internet from real clients? And that was a real struggle for us because, like I said, our support organization had, as soon as they went out to the internet, it was over IPv4. So really, that was a lot of bureaucracy in getting our own internal IT department to turn on IPv6 and set up gateways internally. To turn on, IPv6 for, say, www.f5.com, that was the easy part. To allow our support organization to actually test it over the internet, that was more difficult. That took a long time. And in the meantime, we relied on a company that's out here called Hurricane Electric. Because they, if you have a fixed IPv4 address, you just call them up and they'll give you a free tunnel. And essentially, a lot of our support engineers ended up having call Hurricane Electric set up an IPv6 tunnel. And then they said, well, you know what? I had to clock out early because I can do my IPv6 testing from home, not here at the office. I'll see you in about half an hour, and I'll be working, for the next couple hours until it's all done.
Good, good. Well, thank you for your insight on this question. Now, being a IPv6 evangelist myself, we have seen this evolution, right? So we started to work on IPv6 maybe, 10 years ago. I remember, working as one of the consulting engineers in Cisco in APAC region, working with Entity East, back in like 10 years ago, before their FLETB broadband deployment. Now, when we talk about the enterprise, initially what we were basically talking about initially it was all about getting some of the tunneling stuff done or some of the dual stack being deployed within the enterprise. But now, this is sort of a good segue into the next question, that we have recently been through the World IPv6 launch, right? And one of the big application of World IPv6 launch was the IPv6 Internet Edge, right? So people could get to your website using IPv6, right? So my next question is that while all our panelists over here, their companies were part of IPv6 launch, so they were all, their websites were accessible through IPv6. So my next question is that, getting ready for that World IPv6 launch, what were some of the key technical challenges? And the first question, John kind of brought up, and a couple of other panelists brought up, that one of the key things they saw was the executive buy-in, right? More than technical issues, there was executive buy-in. When the executives were behind you, you were able to kind of do the technical pieces. But now, just kind of coming to one step down, and while getting ready for the World IPv6 launch, what were some of the key, technical challenges you saw, and how you kind of overcome those those technical challenges to getting ready for the World IPv6 launch?
Okay, so for the work we did for World IPv6 launch, which was enabling www.cisco.com, it started, once we had the buy-in, it really started with getting out there and talking to our CDN provider, our ISPs, taking a look at our own infrastructure. We ended up doing a lot of software upgrades to get the features and functionality we needed on our own network, but we also ended up having a lot of good conversations with our CDN provider, and making sure that they were actually able to deliver the service that we needed over IPv6. With the ISPs, I think we had some good fortune there with the work we did for World IPv6 launch, because we found that the ISPs we were using were actually able to support dual stack on existing connections, with the exception of one. We had to swing one circuit over to a different infrastructure on their side.
Without calling names.
Yeah. Since then, we've had some other challenges related to ISPs, but for that experience, it was pretty simple for the most part. As far as the technical challenges go, we solved the problem with the reverse proxy, so we were able to essentially front-end the web servers with the reverse proxy and really mask IPv6 from the web servers themselves. I think the final challenge that I'll point out is with the applications, some of the applications we had behind www.cisco.com. We found that IPv6 is, IP in general, is sometimes visible to applications. We have applications that are doing things with IP addresses. So for example, web analytics systems, they're oftentimes capturing IP addresses, they're storing them, they're reporting against them. We have geolocation services that are trying to figure out where a specific source IP address is coming from around the world. Those are very important in some of the applications we had. So what we found is what we had to do was actually go and either make some configuration changes to application environments, or we had to do some development work to modify the application such that it could behave properly over IPv6, or with IPv6 data, I should say.
So we had a number of different properties that we wanted to make sure were reachable by IPv6, and we didn't. All of the technical challenges are known, a lot cited by John. So nothing like that is completely rocket science. I think the big challenges we had were more in communication, and also just for some of the properties we should have started much earlier, and we ran into things like with geolocation or certain APIs or analytic servers not supporting it, and also a couple of production schedules which just were no-goes. We couldn't make some of the updates because other updates were happening and so on. So I would actually say that getting the buy-in was okay, but then just being able to sort of do from a full end-to-end point of view and all of the systems involved, getting sure that everybody was on the same page, everybody was knowledgeable, and having enough time to test and to make sure everything was working. I think those were the big challenges.
For us, we discovered very early on that not all IPv6 is created equal. That unfortunately, there are a lot of different implementations, and even with various CDN providers, V6 is actually delivered or supported to varying levels. So we actually ended up taking a acquisition website and posted it using a front end. And it was interesting because we did it in such a way that it was totally transparent to the organization that owned the website, and we were able to deploy it and then actually turn it on, and then we went and asked them, oh, by the way, we've turned this on, can we go ahead and broadcast it? So they initially said, are you kidding us? But then whenever we actually demoed and showed them what was actually up and running and working, it was totally transparent to what they were doing. It was a very easy sell at that point. So picking your battles and marketing it appropriately, because it's normally not as big an undertaking as what we initially thought.
Very good.
Well, for us, there was a couple of things. One was, convincing people how to present the V6 site on the internet as far as DNS goes. When we first got, Facebook up on IPv6, the address was www.v6.facebook.com. It existed as a quad A only, because they weren't really to just jump in there. It took a while for them to get comfortable with it, and then they did dual stack, so then www.facebook.com, had both A and quad A behind it. And the same thing with www.f5.com. Right? And so really what it boiled down to is, when is it safe to serve, a quad A record? Because as you know, operating systems nowadays, at least the recent ones, ask for a quad A first and then an A. And most people don't really have IPv6 access. So if they ask for a quad A and you give it to them, then they kind of sit there spinning for a while, saying, well, how do I get here? And then, it's no fault of your own, but your website basically looks kind of broken. So at F5, we basically said, if we're getting a quad A request on an IPv4 listener, we're not going to give you anything. We're going to give you an NX domain, so you come back with an A request. Because then, because if you actually come and give us a quad A on an IPv6 listener, then we know for sure you can handle coming back on IPv6. Facebook, on the other hand, they had a DNS whitelist. Essentially, they had a list of all these LDNS servers from ISP service providers who guaranteed that they would provide IPv6 connectivity. And unfortunately, they weren't willing to share that with us. Now, the other, go ahead. You had a question?
Well, a comment. The projects you're describing
Yeah,
True.
just a second. Could you please repeat your comment? Because we have, whatever you see over here, the number of people, we have 100 times more on the,
Sure,
in
no
our
pro- no
community.
problem.
So this is being live broadcast right now. So there's a live video stream. So for the people on the online.
Yeah, my comment was that when you decide whether to return a quad A or an A based on how it arrives at your DNS server's listener, the problem with that is it assumes that the DNS client you're talking to directly is actually the client that's going to be going to the web service, and that's almost never the case.
Right. So, I mean, it's an indirect thing, and it's basically a best guess kind of a deal. But in general, if the LDNS server is making quad A requests on an IPv6, address, then you know that ISP, their infrastructure, is really set up for IPv6. So it's like 99% sure that any client going through there is probably going to be able to communicate back to you on IPv6. So it's more of a thing where if we do that, we're probably cutting out a decent number of people who could handle IPv6. But it's more of erring on the safe side. Now, the other thing that we came across with was that it turns out that most of the people who are using IPv6 out on the internet are doing so through a tunnel. They don't really have direct access out there because ISPs just aren't providing that to the end, residential customer. And when we were doing all of our testing in the lab, it was just, hey, straight IPv6 to IPv6. So it turns out that when you go through a tunnel, that tunnel encapsulation, shrinks the MTU. And so what happened was when we were broadcasting full out, it was getting fragmented before it came through to the tunnel onto the other side. And we got a lot of complaints that, your site really sucks. It's slow as crap, And when we did the debugging, we realized that through a number of different ISPs, because it was going through a tunnel, it was getting fragmented. And so what we had to do was, on our IPv6 facing, internet facing stuff, we shrank the MTU to account for the encapsulation of a tunnel. And so our performance is not optimal if you were straight on IPv6. But what it means, but it's still, pretty good, and that means that all the people behind the tunnel were no longer getting fragmented, and their performance went way up. So that was another compromise we had to make. And it's one of those things where when people are natively on IPv6 as opposed to going through a tunnel, you won't have to make any more.
Good. So guys, as we talked about, we also saw sort of this evolution, right, within the enterprise deployment. Initially, we kind of started with having some tunneling mechanisms going, and then to dual stack environments. And then we recently saw this World IPv6 launch, which was mainly about, to get the IPv6 Internet Edge capability available, right? So my next question is that as we kind of move forward in this evolution of the V6 deployment throughout the enterprise networks, what are some of the key projects within your enterprise networks you are working on? And specifically, just as Kumar has the presentation just before the lunch about our experiences with BYOD. And in this case now there's a separate name, it's called BYO6D, right? And also IPv6 Wi-Fi, right? So generally what are some of the key projects you guys are working on or trying to get to the next step with the V6 deployment or the rollout? And also, what are some of the things you're doing for BYO6D and IPv6 Wi-Fi access?
So within Cisco, the primary focus right now is on deployment of dual stack widely throughout the enterprise. And right now we've probably got about a few thousand users that are sitting behind dual stack networks today. A long way to go there, so deployments continue to roll out. In addition to that, what we're also trying to do is really get up the stack and go after some of these applications and services that are riding over IPv6. That's a challenge for us, is to be able to work with those teams that are playing in that area of IT. And we're still, spending a lot of time educating them about what IPv6 is and why this is a good thing and why the internet is evolving towards IPv6. As far as getting into the BYOD space, by virtue of the fact that we're deploying dual stack into our desktop networks, that means we're going into both wired and wireless networks in all of our buildings. I haven't seen a lot of good feedback around mobile devices in particular on wireless networks. I haven't seen a lot of problems yet, and I think that's probably because I think IPv4, being dual stack, I think IPv4 is probably masking a lot of the issues. So I think what will happen, I think what we heard from Kumar was, you know, when you take v4 out of the picture, a lot of these issues start to creep up. So I think by virtue of the fact that we have dual stack, we have some latent issues that are kind of hanging out back there, but are being masked by the fact that we have IPv4 that's kind of keeping everything held together.
So similarly, dual stack, both wired and wireless, is pretty straightforward now internally. We do have a lot of, let's say, I'll call them more like labs where we're looking at then getting specific applications running, and a lot of voice, a lot more of unified, let's say unified communication, et cetera, and trying to do more of that more over IPv6, since that generally does suffer the most from applications when you start putting them through NATs and through gateways, et cetera. So we're playing around with that a lot, mostly to try to get more recommendations, since we're obviously involved in making clients and making devices that would do that, and also bringing your own devices. So trying to enable that. But that works pretty well when you're doing it in a smaller lab environment where you have a lot more control over, having less stringent, let's say, firewalling and proxying requirements from the corporate network. I think that's something that we're going to need to investigate more of, how to simplify that and what are some solutions for that going forward, because whenever we try to do it as a larger pilot, that's where things always break. So I would say if I would have to make a recommendation, I'd like to see more of how to get that through security appliances and such things.
Very interesting. Yeah.
For us, we've got a number of initiatives. We actually created a IPv6 program to act as an umbrella for all of our corporate IT and global IT. So underneath that, we actually spun up a number of key initiatives to get strategic infrastructure in place, monitoring, DNS, and some basic security scanning. Once we got those deployed, we were pretty well equipped and have actually gone in and done rollouts in several of our strategic data centers. And very successfully, and interestingly enough, my program, the IPv6 program, is considered to be one of the cheapest in the corporation, because we actually put a policy in place about 2 years ago that said that any new technology come out had to include IPv6 in its architecture and design, or an IPv6 adoption plan. So things that we're looking at right now are ways that we can really leverage IPv6 address planning and automation to actually realize some return on value. And you may have heard a little thing called Cloud Initiative recently that was announced. And my word to anybody that's considering cloud is, if you're looking at cloud solution, whether you realize it or not, you're looking at IPv6, because the scalability and the size that you're looking at is such that it requires IPv6 addressing in order to be effective going forward.
Very good.
Okay. Well, for us, what we've seen is really, IPv6, and bring your own device. It really is device dependent and also carrier dependent. How many of you guys have, one of these guys, iPhone or Android or, what have you? So there's a nice tool that you can download for iPhone. I'm sure it's on the Android space too, called Ipv6 Toolkit. And one of the things it allows you to do is check and see what your network settings are. So this iPhone 5 happens to support both IPv6 and IPv4, but right now with Ipv6 Toolkit, I can see that I'm on the AT&T network. I've got a 10 dot whatever private IPv4 address. So the truth is that AT&T, Verizon, you're all on IPv4. You're on some sort of private, either 172 or 10 network space, and it's being gatewayed internally, NAT 4 to 4, or throughout in order, for you to actually get out where you're going to go. So there's a couple of things. One is your device may be able to support it, but your carriers don't, at least not in the US. In Japan, that's a different story. People are really pretty much on IPv6 there. So when it comes to bring your own device, you're not going to see them coming in via IPv6 anyway. But the other part of it is that in order to get them securely onto your network, you have to have some sort of edge client app that you can download onto your device, right? And when it comes to edge client apps, what we noticed is that there's a difference in the operating systems. In order to get you a secure connection, that operating system has to give your app hooks into various things that it's doing to make sure that you can't go around it or do split tunneling or some other thing like that. And so in that regard, iPhone's great. iOS 5, iOS 6, even the previous versions were fine for that. They allowed you to do that. Android, not so much. It turns out that before Ice Cream Sandwich or Android 4.0, the hooks to do a good SSL secure tunnel in there didn't exist. And what happened was it was dependent upon the different phone manufacturers to put those hooks in for you. So Samsung was good for that. So even the Samsung ones that are running Android 2.2 or whatever, you can do that. But some of the other manufacturers, not so much. Not until you get to Ice Cream Sandwich or Android 4.0. Now BlackBerry allows you to do that, and the new Windows 8 also allows you to do that. But at least as far as F5 goes, they're concentrating on iPhone, iOS, as opposed to Cisco iOS. They're concentrating also on Android, and we are also doing some stuff on the Windows 8 RT. And I asked about support for BlackBerry, and they said that's last on the list and maybe never. Good.
Hey, John, based on your work in the mobile space, did you have any comment on this about the headsets?
I think that this is something that's been worked on for some time. Wi-Fi, most all of the major modern mobile OSs support it over Wi-Fi, so that works well. So if people bring in their own devices and connect over Wi-Fi, that works. But then over cellular, I guess Verizon has been a little bit more bullish, and T-Mobile as well. I think T-Mobile, I noticed with their latest Windows 8 devices are doing dual stack, but they've been doing trials on V6 for 4 years or so. But otherwise, still, the carriers are not aggressively deploying V6 over the cellular networks too much. They're playing around with it, but they're not really making it available to end consumers yet. So at the end of the day, maybe you can do it from an enterprise point of view if you're over Wi-Fi, but that's about it. That's all. That's the most that you can expect.
Good, thank you. Now at this point, I would like to take some questions from the audience. Any specific questions about some of the challenges you're running into while deploying V6 in your network, or any other technical or general question for the panelists? Can we get the mic, please, to the gentleman in the red jacket?
Testing. So talking about getting the upper level buy-in from a corporate aspect, one of the big selling points that we've been trying to move with the DoD and the military sectors that we've been working with is the theoretical max throughput of IPv6. Packets are slightly larger, so over time it's an increase on the throughput of the processing in the device. But when we do actual throughput testing, what we're seeing is lower performance statistics on devices that are dual stack enabled or native V6 enabled over IPv4 only type of configurations. What we're guessing that is are things like the ASICs and routers and switches being directed towards IPv4 traffic. Are there any types of hardware considerations like that that we should be looking for to see if we can kind of highlight that selling point of you'll get a better bang for your buck by running V6 over V4 that's being NATed or something along those lines?
Sure. Who would like to take the question? Sure.
I'll just jump in and say that we haven't, being in my organization, we haven't done as strenuous of testing as it sounds like you do. But in our production network, we haven't run into any issues yet related to performance and really pushing the performance threshold yet. But maybe there's some other panel members here that may have some more experience doing this kind of testing.
Yeah, we actually did a pretty extensive proof of concept because we do have well-defined standards for hardware and software. What we found was that IPv6 on a software implementation, rather than being actually implemented in the hardware ASICs, the performance was dramatically reduced. And especially whenever we started hitting the higher bandwidth applications and stress testing, we've started running into some definite behavior and performance problems at that point. So the thing that I would take away from this is to tell you to work with your vendor, make sure that they understand that V6 is a priority for your organization and your business strategically going forward, and help them understand where those deficiencies lie so that they can be addressed.
Okay.
Yeah, so I would say that one of the things you have to look out for also is sort of how the IPv6 stuff was implemented. If you're looking at a shim on top of existing IPv4 code, that could definitely account for some slowness. At F5, what happened was they basically rewrote the whole core of the stack to be IPv6 from the ground up. And in actuality, when you're using IPv4 over F5 stuff, it's actually a software shim to make it look like it's IPv4, but actually underneath the covers, it's really IPv6. But what we noticed, or what I've seen actually, is that it wasn't so much IPv6 versus IPv4, but us going from a 32-bit code to 64-bit code. It turned out that, yeah, sure, we can access a lot more memory and we're more flexible, but in fact, our connections consume more memory now, so like our maximum connection count went down, and just in general, the 64-bit processing just a little bit slower than the 32-bit processing.
Very good. So,
And I was just going to add that, 2-3 years ago, we did see some issues with some older network platforms that were switching packets in software versus in hardware. But more recently, as we've moved to the newer generations of hardware, we're not seeing those problems anymore. So that's kind of a thing that we did see in the past, but we're not seeing today within our production network.
very good. So basically, the question was about, some of the performance concerns, right? Or what could happen or what could cause them. So I started to work back in 1995, started in Cisco as a TAC engineer, right? So basically, one of my colleagues, I remember that until now, he said, you cannot put 5 pounds of sugar in 10 pounds of sugar in a 5-pound bag, right? So what it really means that you got to do your homework, right? You got to see under the hood how the implementation has been done, right? Because if you just take one example, right, of running OSPF version 3 in your network, right? So now you're going to be running 2 distros, 2 SPFs, right? So you got version 2 for V4, version 3 for V6, right? So you got to have enough, processing power, enough memory, all of that stuff. Hardware implementation has to be in place, right? So you got to do the homework, you got to do the testing before kind of getting it to that point that when you're running into issues, right? Because if you have done your homework and you're kind of doing a phased deployment, so you'll see some of those issues really early in the deployment. Any other question?
Yes. What tool are you using for your DDoS protection on IPv6? Not only at the network layer, but also at the application layer.
Could you repeat that? I couldn't hear.
What are you using to protect against DDoS
Oh, okay.
at the network layer and
DDoS.
application layer?
So basically, what tools are you guys using within your enterprise network for the DDoS meditation?
Well,
Mediation?
So, well, I mean, you know, F5 and Cisco, we produce products to basically do this. And obviously at F5, we have what we call our dog food program, which says, you know, basically use your own equipment for that. So when it comes to DDoS, I mean, it starts at layer 4 with SYN cookies, you know, and then it goes beyond that to doing, you know, session checking, just making sure you have enough SSL capacity, and then at layer 7 checks, looking at URI patterns and who's coming in there, and even making use of external services like something like an IP intelligence to try to figure out, you know, who might be bad actors out there. But frankly, we've never seen a DDoS attack over IPv6.
That you know of.
On my side, the area I know best is the network, you know, layer 3. We use NetFlow-based techniques. We leverage our own products in combination with products from companies like Arbor to protect against these kind of threats of DDoSes. And to date, what we've seen is we're happy with the solution that we have. In general, we're seeing comparable functionality when it comes to DDoS mitigation with IPv6 as we have with IPv4.
So you're looking at the link list within the packet, or you're only dealing with layer 4?
We're dealing
That's
with
the issue
we're
for the
dealing-
DDoS tools.
Yeah, so we're dealing with layer 3 and layer 4 information.
Well, we actually are just concluding, taking a look at some of this, and what I would tell you is there are lots of different options in the DDoS mitigation space right now that support IPv6, and it seems to be very specific to your own requirements as to what solution really fits best within your space. So, and of course, once you've got a solution in mind, test it to make sure that it does meet your V6 requirements.
Yeah, I'll just say that actually this is one of the areas that is sort of slowing than the actual deployment of widespread deployment of V6 for us. We're being overly cautious, and I know that there's a lot of vendors there who are doing dog fooding, so we're sort of sitting back a little bit on that.
Yeah, one thing I should mention is that I have personally seen DDoS attacks generate a lot of traffic. In the spring, I thought we'd reached a new high when I saw 30 gigabits per second of DDoS traffic directed at a single target. And then later on this fall, that was exceeded. We saw people being able to generate 50 gigabits per second. And if you look at that, that was all IPv4.
Good. Also, one of the points I think, you know, like which panelists mentioned about like looking at the DDoS, different tools and stuff. Maybe not your favorite vendor has the best solution, right? So you have to kind of see what fits in your particular environment and what's best for your network. Yep. Just a comment.
Owen DeLong, Hurricane Electric. It's nice that you haven't yet seen a DDoS on IPv6. Congratulations. It will come. We have seen some attempts at it. We haven't so far seen more than about 1.5 gig of IPv6 DDoS traffic, so we kind of looked at it and went, hey, look, at least there's a DDoS now. But, you know, we thought it was kind of cute, actually. We do occasionally see scanning attacks. The longest one I think we saw was a guy that spent 3 days and worked through the first, you know, several million addresses of a /64 before going away. But, you know, the malware and the spyware and the adware and the other bozos out there are starting to catch on to this IPv6 thing as well. So
Yeah. Well, I mean,
it's not something you can completely ignore or pretend V6 is immune to.
No, it's certainly not. But, you know, in truth, all of those attacks that you see out there for the most part are, you know, what they call the script kiddie tools, you know, low orbit ion cannon, you know, things like that. Those things are above the IP layer. They're pretty much operating at layer 4 through 7. And so that's all abstracted away from them. They don't really understand what's going on. And it just depends. Is the computer that they've managed to hijack on IPv6 or not? And really, that's what's going to determine whether or not they get there, right? So, for the most part right now, most of the people who are stupid enough to click on the, oh, look, win a free iPad, and then now they're a bot, aren't on IPv6. But like you said, that's going to happen, and when it does, there's nothing special about IPv6 and DDoS, right? Mm-hmm. Whatever works for DDoS on IPv4 is still going to be the methods that you employ, the strategies that you use to protect against DDoS that's coming over IPv6.
I would actually say, from our perspective, IPv6 DDoS attacks are a major concern because most enterprises and vendors do not have IPv6 visibility at this point. And so there's a good chance that, they may have v6 running on their networks they don't even know about, and they're being, used for botnets or whatever, or to try deeper penetration. In fact, that most of these systems are dual stacked makes them doubly exposed.
Good. I'll take the next question from the audience.
Thank you. John will remember that a couple of years back we made quite a number of presentations praising the virtues of IPv6 in a mobile environment to save battery life. Reason was you don't have all these keep alive messages. Now the world is even more mobile broadband, machine to machine. What about the reviving the argument of IPv6 to save battery life?
So I'll just sort of summarize. Basically, when you're a mobile device and you do not know, if you're behind a NAT or not, we did a lot of testing, this is a number of years ago, on having to generate keep alives to be able to refresh the state in the NAT. Some of that has been a little bit modified by carriers rolling out large-scale NATs, 444, et cetera, type of things. But still, basically, the general theory is that sending a packet is much more expensive for a mobile device than receiving it, because that's just the nature of the radios, especially cellular. So that having the devices needing to be regularly sending out packets will really dramatically affect battery life, so that if you have always-on connections, that will dramatically decrease the battery life. And still, I think that like Verizon has been pretty aggressive, at least in some ways, of moving to LTE and wanting to go with voice over LTE, because then LTE is only a packet-only network. So when they run voice over that, then they want it to be V6 only to get out of all of these sort of issues about having to maintain state in the network, having things on the data path that has to have state, and those boxes are expensive and more expensive to manage and control. So I think from multiple areas of improving battery life, performance, and also just network performance, that they're looking at that. I think though still a lot of devices are still not necessarily spending the majority of the day on IP connectivity, so that they basically hibernate. And it's only going to be once we start moving towards more of actually running voice over IP or voice services over IP, that then this will start to be really a bigger impact.
Actually, I think the real problem is a mismatch in terms of the incentives of the various players involved. If you think about battery life, right? Who looks bad because the battery life is bad? Yeah. It's not the carrier, it's the cell phone companies, right? It's if Apple says our phone battery lasts longer than Nokia or whatever, that's who's impacted by that, and they don't have any control over the carriers. If the battery on your phone is dropping faster, you don't blame AT&T or Verizon.
Yeah.
On the other hand, if you take a look at the phone companies, they're spending millions of dollars every year on, well, actually tens of millions of dollars every year on essentially expensive NAT hardware. Why? Because they don't want to have to redo all the IP addressing on their networks. And that to them is, they believe that's going to cost them a lot more than all that NAT hardware that they're buying every year. And until they basically reach the point where they realize, you know, if I bite the bullet and re-IP everything, that all goes away, and I can basically save tens of millions of dollars of capital expenditure every year. You know, that's what's going to be the tipping point. And you know, until that time, I'm happy to make a lot of money selling them NAT gear.
Well, and also though, a few years ago, you know, before, or let's say about 5 years ago, before this started becoming a deployment issue, there were a lot of network engineers and carriers who also liked the idea of being able to put everything through one box. That gives them more control. And then I remember sitting in some meetings where we were getting asked, hey, can you do deep packet inspection to block out the Skype bits and so on? And people were really looking at that way to do more monetization by figuring out, is this an expensive bit or is this a cheap bit that we're putting through? And now it's pretty apparent that actually, at the end of the day, capacity is the bigger issue on the cellular networks. So you're getting a lot more of carriers interested in offloading because they're starting to max out, and depending upon how they've deployed their network, there are different bottlenecks in their networks, and often some of the NATs can be an issue. So from a network performance point of view, I think that's going to be more interesting for V6 going forward.
Thanks a lot. We have another, I'll take the last question from the audience, and then I have one question, and then we'll wrap up the panel discussion.
So I'll piggyback on Eve's question about the keeper lives. I think in IPv6 there is also a keeper lives involved. That's called router advertisement. So how would you compare the different methods of address assignments and battery life, if you have experience?
Well, actually, what the 3G networks have done is they created a sort of odd way of doing address assignments. So they're not having those router advertisements necessarily. Basically, the interface ID is getting defined by the is it the GGSN and assigning it, so you don't necessarily have that router advertisement traffic over the air interface. But over Wi-Fi, you probably will have it.
Good. We have like almost 5 minutes left, so I'll just give 1 minute to each panelist. And my last question is that, I consider all of you been engaged in this journey, right? And if you were going to do it again, let's say, what would you do different, and what advice you have for our audience here and on the internet?
What would I do different? I think what would have made a big difference for me personally and would have saved me a lot of time was getting to my CIO about a year earlier than I did and really planting the seed there.
Executive buy-in.
Yeah, I without that, I ended up spinning my wheels a lot. And once I had that buy-in, things started kind of to click and really move along. So I would say, looking back, if I would have done that about a year earlier, I probably would have been in a lot better shape and I wouldn't have had to do as much legwork on my own.
Good.
Thinking about this, actually, we had some very early deployment of IPv6, and we assumed, okay, that's it. We've got IPv6 addresses on all of the endpoints in the lab, and people can connect their laptops or whatever to that, and that's fine, done deal, and let's move on to something else. But the complexity of enterprise networks is pretty large, and a lot of that was not thought of up front. So I think probably realizing that there was a few more layers to look at, especially the application layers and the applications, and putting that as let's say phase 2 would have really helped a lot. Also, just to toss out as an idea, if we also had a sort of more tangible end user application that people could see and play with and get more hands-on experience that was native v6. I think that would have also been something that then you could clearly have as a sort of ability to show people, hey, this works like this, and this is something people can use, but then once you move back to v4, you don't get this.
Very good.
I would say really engaging marketing to help them understand the value of IPv6 and engaging our vendors earlier so that they really had more of a stake and involvement in the process. Because when you look at it, it's almost like your company is acquiring itself, or that you're taking 30 years plus of internet evolution and trying to come out with a new addressing model and environment. So, you know, being able to actually engage the stakeholders, marketing, the vendors, and, you know, focus from that directive.
Well, so there are a couple of things. One is, aside from the U.S. government, it seems like Korea and Japan were the ones who really have taken IPv6 and run with it. So if I had to do things over again, I would have asked my bosses to let me sit out for a week or two in Japan and, you know, to sort of absorb what they're actually really doing. It was either that or a skiff in Washington, D.C. somewhere. I would rather go to Japan. The other thing, though, was that for us, the biggest pain was to get our support organization, native IPv6, access to the internet so they could actually test these things for our own customers. And, you know, my company is headquartered out of Seattle. Unfortunately, I'm based down here. So when I'm complaining to our CIO, it's over the phone. I would have spent more money on airplane tickets so I could have sat and across from him from the desk and said, I'm not leaving until our support organization gets IPv6 access.
Very good. So just to kind of summarize, you know, what I kind of heard from all four panelists about what they could have done differently, or what's the advice they have for our audience here and on the internet, is one is executive buy-in, early executive buy-in, right? The other one is pre-deployment testing, extensive testing, right? The other thing is doing training, right? Training specific for different roles within an organization, right? Getting the vendors who are making this equipment involved and engaged and making them your partner while during this journey. And the other important point also made is to really observe that who are the key folks who are leading the pack, and kind of working with them to absorb early in the game that what is really is going to happen. So with that, you know, we'll end this panel discussion. I would again like to thank all the panelists to be part of this discussion, and special thanks to John. Earlier this week he ripped his ACL, torn his ACL, but still he made it to the panel discussion. And to Rich flying out from Dallas, and to John, and to Patrick, really appreciate it. And hopefully you guys enjoyed it, and it was a good learning experience for all of us. Thank you.